Moving on to question 4, it says at time t equals 0, a boiled potato is taken from a pot on a stove and left to cool in a kitchen. The internal temperature of the potato is 91 degrees Celsius, with the internal temperature of the potato being greater than 27 for all times t greater than 0. That's going to be very important for us. The internal temperature is given by this differential equation. Notice that this differential equation is in terms of our dependent variable, not our independent variable. This is something we've seen quite a bit of on the AP exam. In part A, they want us to write an equation for the line tangent to the graph of h at t equals 0. Remember that a tangent line can be written in the form y minus y1 equals my slope times x minus x1. And luckily I know what x1 and y1 are. That's going to be the 91. So all I need to do is figure out what this slope is, and I'm good to go. My slope is going to be whatever the derivative is for h, but notice that h is 91. So I end up with negative 1/4 times 91 minus 27. And this is a perfectly legitimate answer, although it would be helpful to know that this comes out to be 64, and so I could really write this as negative 16x plus 91. Now, this is a perfectly valid answer. Of course, getting rid of that 64. This is a perfectly good tangent line. But knowing this little tidbit can make further problems a little bit easier. The calculation's not too difficult, but there's no reason to make that calculation if we don't have to. Part B wants us to find the second derivative of h with respect to t to determine if this is an underestimate or an overestimate at time t equals 3. Wait, did I finish answering that question? I found the tangent line and then used this equation to approximate what happens at t equals 3. So y of 3, in other words, h of 3, is approximately equal to negative 16 times 3 plus 91. And again, I can leave my answer like that, but it might be helpful to know that 16 times 3 is 48, and 91 from 48 is 43. And because they do mention units, it would be really helpful to put our units here, 43 degrees Celsius. All right, moving on, I'm looking for the second derivative. So that's really the derivative with respect to t of dh dt. So I'm looking for the derivative with respect to t of this negative 1/4 h minus 27. But keep in mind, this is not t, this is h. So if I take the derivative of a scalar multiple, that negative 1/4 will stay there. The derivative of h is dh dt minus the derivative of 27, that's a constant. So I really end up with negative 1/4 times dh dt, which is negative 1/4 times h minus 27. Now, I look at this, and I notice that this is always going to be greater than 0 for two reasons. One, this negative times a negative is going to give me a positive. And for two, I know that h is greater than 27, so h minus 27 is greater than 0 for all t greater than 0. So since h is concave up, what I'm looking at is the tangent line approximation that I had for a concave up graph means that my tangent line is going to be an overestimate. So part A is an overestimate. Now, the biggest mistake is that people are going to want to say that this is really negative 1/4 of t minus 27 and just say that the second derivative is negative 1/4. But that causes a lot of problems. One, because you're ignoring the change in h. And two, if it's negative 1/4, this is actually going to be concave down and give us an underestimate, not an overestimate. But because our tangent line lies completely above this curve for all t greater than 0, then this tangent line has to be an overestimate. Finally, moving on to part C, this is our solving a differential equation, the five-step process that we've talked about. Keep in mind, the five-step process, what we're doing, the first thing we want to do is separate our variables. So I've got different variables here. I want to make sure all of my dependent variables are on one side, my independent variables are on the other side. So g is my dependent variable. I want to move this g minus 27 to the 2/3 power over to the left side. And that means all I'm going to have on the right side is a -1 dt. So that's my first step. My second step is to integrate this. So, of course, integrating this side is just going to give me -t. Integrating this side is going to give me, let's see, this is g minus 27 to the -2/3. So adding to this is going to give me g minus 27 to the 1/3 divided by 1/3, so really multiplying by 3, equals -t plus a constant. Remember, step 3 is we have to have that constant of integration. Now what I want to do is solve for g, and then later on I'll use this tidbit of information to actually solve for my constant. So first thing I'm going to do is move the 3 over. So g minus 27 to the 1/3 is equal to -1/3 plus a constant. I'm just using a different letter to signify it's a different constant, but it is a constant. Then I'm going to raise each of these to the 3rd power. So this is going to be really k minus 1/3 t over 3, excuse me, t over 3. Horrible mistake. To the 3rd power. And then I can move this 27 over. So what I've got is I've got g of t is really equal to my constant minus t over 3 cubed plus 27. And now I can use this tidbit here. So I have 91 equals, this is going to be k minus t 0 over 3 cubed plus 27. So 91 equals my constant cubed plus 27. And 91 minus 27, as we saw before, was 64. So for us, k is 4. So our function is g of t equals 4 minus t over 3 cubed plus 27. And then I can just go in here and substitute what happens at t equals 3. So I get 4 minus 1 cubed plus 27, which ends up being 54 degrees Celsius. Now, keep in mind that we were talking about the previous answer that we had being an overestimate, so we've got another one here. So that's problem 4.